Hey folks, it's Michael Johnson. Welcome to this week's Energy Sketch. We're going to talk about microwaves today. Microwaves to the rescue. I saw a news article recently from this company, Pyrowave, a Montreal-based company, and I've spoken previously about Aurora Hydrogen also. So we're going to dive into a little bit of details on the magical, mysterious world of microwaves and what they're good for. We'll start with Pyrowave, and they have sort of two or three different things that they do with microwaves. And the first thing, their sort of innovation was around using them for plastic recycling. So you load up a hopper, a reactor, a microwave oven, a big microwave oven. You load it up with particular types of plastic, blast it with electricity with microwaves, and then it converts that into like oil and like sort of makes it into prime materials that can be used again for forming different types of plastics. So essentially, it's like a plastic recycling and upcycling via microwaves. And they've also been in the news recently for an innovation around cement production. So I'll sketch you out a little bit here what cement production is about and how they use it with microwaves. It's pretty cool. So cement needs something called clinker, which is kind of the glue that holds stuff together, that holds the aggregate together. Concrete is kind of like a mix of aggregates of different sizes along with a kind of a glue that holds it together. So the raw materials for that are limestone and clay and other sort of minerals, but primarily limestone. And currently in the cement production, it goes into a kind of a reactor. And what they do in that reactor, and the final product is this stuff called clinker. And what they do in the reactor, they need to heat it to high temperatures. So typically they burn coal, biomass, natural gas, diesel perhaps, probably less, creating high temperature heat. And that combustion process emits CO2. And there's also CO2 emitted from the calcination of the limestone. So the limestone converts into calcium and other products and releases CO2. So there's a double hit of CO2 here in the conventional cement production process. And so what Pyrowave's technology does is you take away this as a heat source, and instead you blast that limestone with electrically produced microwaves that heat it up. And so there's another side benefit also. You're removing the CO2 from the combustion, doing it with clean electricity, and also you're apparently concentrating the CO2 stream here. And so it's more able to be integrated with carbon capture technology that could be necessary for fully decarbonizing cement production. So that's pretty cool. Pyrowaves technology, they're a Montreal-based company, and links are in the description. The other company to highlight that's using microwaves is Aurora Hydrogen, another Canadian startup. And they do methane pyrolysis. So take that sort of reactor, that container, some type of a microwave appropriate container that you're blasting with electrically produced microwaves, same as in the cement production, kind of. I mean, the concept is the same. The details are quite different. So here, Aurora Hydrogen, what they do is they feed in methane and then blasting it with these microwaves in a way that heats it up to high temperature and splits it into hydrogen gas that can then be used for all of the things that we want to use hydrogen for and that we do use hydrogen for today: power generation, ammonia production for fertilizer, fuel production, all sorts of industrial chemicals are made using hydrogen. And the other byproduct is pellets of the other atom that comes in natural gas that we don't want going into the atmosphere. That's carbon. So the carbon comes out as solid pellets. And this is really one of the potential game changers here for this methane pyrolysis. And there are many startups looking at it in all over the world. Really, I'm highlighting here Aurora Hydrogen because I know one of the professors from the University of Toronto. Hey, Murray. So good job and keep it going. So this is really cool. The potential game changer here is that the carbon is solid and can then be used in other industries, in aggregate, in materials, part of steel, all this stuff. And so really cool potential there. Instead of needing complicated, expensive, big infrastructure to capture dilute streams of carbon dioxide. This technology allows that carbon to come out in pellet form that's simply and easily then used or disposed of. So this got me on a track of thinking about microwaves, and went on a little literature search here and found this group from Macquarie University using microwaves in a different area for the energy transition, which is around solar panels, manufacturing, and recycling. So, right, the concern here is that we're going to build like these massive solar fields, and currently recycling of solar panels is complicated, expensive, not done very much, so they're kind of ground up maybe. I don't know exactly the details, but we need to really ensure that we have a fully circular economy around all of the new technology ramping up and scaling up for the energy transition. That includes wind turbines and solar panels. So the solar panel is basically made of glass that's very good recyclable glass, when maintained in a separated state from other waste products, then it's very nicely recyclable, nicely circular material there. And that applies to beverage containers and other things. Just another thread for another time around entropy and recycling. But we're talking about solar panels. So the problem, though, with recycling the solar panels is that they have this thin plastic film on the top of them, which is difficult to remove apparently right now, so they're less able to be recycled. So what this research crew basically looked into was blasting this panel with microwaves. And there's a picture of one of the researchers holding a small piece of solar panel next to the microwave. So what this does is it heats up the film and makes it easier to remove. So we could peel it off, and then the glass is in a higher quality state for recycling. So that was pretty cool. And the last thing I wanted to talk about around the idea of microwaves is this concept that's sort of out of sci-fi, but there's been a few news articles recently about some sort of small-scale demonstrations in this space, and that is wireless power beaming. And there's sort of two related, diametrically opposed but related concepts that we'd get into right now. So here, let's picture us here somewhere on the surface of the Earth. And the sun is out there far away and is beaming us energy, right? But we'd like to be able to get more energy than we're able to get on the Earth, perhaps, or not have to take up all of the space that we need to take up right now to harvest that solar energy on the Earth. And also, I guess, outside of the atmosphere, then we don't have the loss of power from some of the wavelengths also that get filtered through the atmosphere. So the idea is to deliver a spaceship with giant solar panels on it, and then make microwaves or lasers or beam power back down to Earth. And we'd have giant antennas that would collect that power, perhaps at a few different locations around the Earth, to then be distributed via, power cables and used in all the ways that we use clean energy on Earth. So that's one concept. So the gathering from the sun onto the Earth, concentrating it out in space and beaming it down to Earth. And there's a link in the description to the Caltech Space Solar Power Demonstrator. They just celebrated a small success of sort of beaming a small amount of power between two satellites or something, roughly in that ballpark there. And there's the diametrically opposed related concept is, say we want to send some spaceships to Alpha Centauri, 4.7 light years away. So that's pretty damn far, and it would take a really, really long time with our current propulsion technology. So the idea here is to make small satellites that would have small little spaceships that would have a solar sail on it. Something like this, a little collector on the back, and we would beam a lot of power via lasers from Earth, something in the order of like 100 gigawatts. Like that's a lot of power. That's quite a lot of cities. That's like a country's scale, I think. And I went down a rabbit hole there on the Breakthrough Starshot. Links are in the description, and some nice concept photos. So that's it for this week's Energy Sketch, folks, talking about microwaves to the rescue for decarbonization, clean electric heating, cement production, methane pyrolysis, helping solar panels to be more recyclable, and gathering huge quantities of power from space and beaming it back to beam spaceships back to visit our neighbors far, far, far away in the solar system. Hope you enjoyed the episode, folks. Tune in next week, Mondays, 12 p.m., youtube.com/@EnergySketch. Take care. Be well, folks. Have a great week. Toodaloo!